I'm Kim McIntosh, and I teach biology at Shadow Mountain High School. And this broadcast is about interpreting graphs. So first we have line graphs, and line graphs always show changes over time. So if you look at this line graph, you can see that it's pretty easy to interpret. You can see that there were 60 swimmers in May, and in August there were 120. And in if you're looking for the greatest number of swimmers, you can see that that was in the month of July. So very easy to interpret. But sometimes more than one line can be placed on the same graph, and so you have to do a little more digging to figure out exactly what's going on here. So this graph has 3 lines on it, and this shows the sales of 360 games versus PS3 games versus the Wii games. Bar graphs, they display numerical data, but that data is not over time. So what you're looking at here is you're looking at a lot of different categories. Those categories would be the different games that Sony sells, and then on the left-hand side you can see that that is graphed against the sales in millions of dollars. Pie charts show the percent of a whole group. So let's say I asked 500 people where they like to go on vacation. Well, then this pie graph would split that up, and it would show what percent of that 500 chose Hawaii versus Bahamas versus Cancun, Jamaica. We also have scatter plots. Now, scatter plots are a little bit different. They're not really line graphs. Sometimes we'll draw a best fit line just so that we can read the data better, but scatter plots, what they do is they scatter the data around 2 different variables so you can see how the variables relate to each other. So for example, this graph here shows Old Faithful eruptions. Down at the bottom on the x-axis you'll see that it has how long the eruption lasted. Okay, and then over on the left-hand side, on the y-axis, you'll see that it shows the wait time between the eruptions. So this graph is trying to relate the eruption duration to the wait time between eruptions. So graphs will show us if we have an inverse relationship. That means as one factor increases, the other factor goes down. All right, so in this graph, it shows that the rate of photosynthesis, it goes down as light intensity increases. Direct relationships occur when the 2 variables go up or down together. So an example of this would be if we increase the temperature of a frog's habitat, the heart rate of the frog is going to increase as well. Now we're going to talk about standards of measurement. So a standard is an exact quantity that people agree to use to compare measurements. So for example, let's say you need to move a desk. You're not sure if it's going to fit in the trunk of your car, and you don't have a ruler, you don't have anything to measure it with. How could you figure out if the desk is going to fit in the trunk? Well, you might use hands. So you might put your hands on top of the desk and count how many times you can put your hand end to end, or you might stand up next to the desk and see how far it comes up on your leg. But those are not exactly standards. So what we have in science is we have this international system of units, and so this is a system that all scientists use no matter what country they're in. And so we abbreviate it to SI so that we don't have to say International System of Units all the time. And for length, we use the meter. So generally we use meter, centimeter, or millimeter. For mass, we use kilogram or gram. For volume, we use liter or milliliter. And metric system are units in base 10. So it always goes by 10. This gives us a really easy way to convert from millimeters to centimeters to meters, because there are 10 millimeters in a centimeter, and there are 100 centimeters in a meter. So it's really easy for us to go back and forth in between those measurements. Now, we're not going to worry about measuring in our normal system of units like feet or inches and converting to metric, we're just always going to measure everything in metric to start with. So our length measurements are millimeter. Those would be really small objects like a quarter. A centimeter would be fairly small objects like your foot or maybe even your height, but that's getting a little bit long. Meter measures larger objects or distances. Like if we wanted to measure the size of the room that you're in, we would use a meter. A kilometer, that's much larger distances. So if we were going to measure from Flagstaff to Phoenix, we would relate that in kilometers. Volume measures the amount of liquid in a container. So it could also be a gas, but generally it's a liquid. This is a beaker, and this is a graduated cylinder. And these are the tools that we use to measure volume. Now, to read a graduated cylinder, you need to have the graduated cylinder sitting on a desk. Don't try to hold it in your hand and read it because you're moving the liquid around inside of there, and that does not work very well. So to read a graduated cylinder, you need to look for this meniscus. This is called a meniscus. See how the level is tilted or curved right there? That's called a meniscus. And what we do is we measure this along that very bottom part. Okay, so we're not looking up here where it's reaching up onto the side of the cylinder. We're looking at that very bottom part. So we would call this 30 milliliters. So over here, this one's clear, so it looks a little bit different, but still you're looking at the bottom of this meniscus. You're looking for that bottom edge there. And so to read this, you have to figure out how many lines are between 50 and 60. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this would be 53 milliliters. All right, the next thing that we will be measuring is mass. And mass is the amount of matter in an object. So it's not the weight of the object, because weight is the effect of gravity on an object. So mass, we're just looking at the matter in the object. Sometimes we use those interchangeably, but they're really different. So to measure mass, we use a triple beam balance. And in order to read the balance, what you do is you want to look at this large one first, okay? This one's set at 0, so we're not dealing with the hundreds here, so we can just kind of skip back to this next larger one, and you'll see that it's on 60. Over here it says 100 grams, so this would be 60 grams. And then we look here, and we say, okay, well, it's a little bit past the 2, and we count how many places. 1, 2, 3, 4 places past the 2, so this is going to be 62.4 grams. All right, and then this one is not as easy to see, but it shows you actually something sitting on there. But this one, you'll see that this is on the 300 mark, and this is on the 30 mark, so there we know we're at 330 already. And then this one is on the 5, and I'm gonna say that this is about 1 past the 5. I'm guessing a little bit there because my eyes are not that good and can't see that picture, but so we have 335.1 grams.